Hi guys, we're starting chapter 11 today. We're actually going to jump to section 3 for the bulk of this lecture, but a little bit of background in section 1. It's all about magnets and electricity. Okay, so quick review. You know this from being a kid and playing with magnets. Magnets have a north and a south pole, and the like poles repel. Okay, they don't want to stick together. It's the opposite poles that attract. Okay. Magnets emit a magnetic field. Let me get my pen here. Get used to this multitasking thing. So look at this picture right here. And what it's showing you is that these magnets have a field coming out that you can't see beyond them. And that's why once these magnets get within each other's fields, they just kind of jump together and stick like that. Okay. If they're repelling, that's why it flips like that and sticks together. The Earth also has a large magnetic field all the way around it from pole to pole, which is why compasses work. Okay? A compass always looks for the North Pole, the magnetic North Pole. But it's also why magnets interfere with a compass. Okay? So you can see that by holding this magnet up to it, it's totally messing with it. All right? All right, let's get into the chapter, starting at section 3. So, all matter is made up of atoms, and those atoms have positive protons and negative electrons, which act very similarly to magnets. The opposite charges attract, the positive charges want to get to negative charges, and vice versa, but like charges repel, okay? Well, if those charges are moving to get to other charges, we have what's known as a current, okay? And that is a flow of electric charge through a material. Typically, it's through wires. When we plug things in, that's what's carrying the electricity is that current. Okay, it's also why you see a plus and a minus on batteries. It's indicating that opposite charge. Okay, when it's flowing through these materials, it brings us back to insulator and conductor. We've talked about those things when we were talking about heat, and it's a very similar definition. An insulator is a material that doesn't allow electric current to flow. It's also a material that doesn't allow heat to flow. And the materials are similar. So like wood and plastic tend to be insulators for both heat and electricity. And a conductor, on the other hand, is a material that does allow heat and current to flow. And that's usually metals, okay? So if you think about an electric wire, all right, so something that you want to plug in, okay? You've got this metal coming out of it. You don't want to touch this when you plug it in because you're going to get zapped. But the rest of the wire is coated in this plastic material. Inside of that is wires. If you cut the wire, you can get electrocuted also, or sparks might shoot. You want to be careful of frayed wires. And I would not recommend touching this at home just to experiment with it. I'm talking to you, Ian. Be careful. So, conductor, insulator. And then lastly, whenever there is an electric current, it produces a magnetic field as well, okay? So I've got some electricity coming through here. This is plugged in. You should be able to see. It's hard to get the compass to respond because it wants to lay flat for this. Anytime you see that needle moving, it's because the electric current is producing a magnetic field as well. That's going to allow us to talk about things like electromagnets in a later lecture, okay? All right, this is the point where I would blow you guys away with this awesome experiment, this awesome demo. You'd also be able to do it yourself, and you'd be like, oh, Mrs. Blaine, I love science. Science is my favorite. And I'd be like, yes, I love my job. But unfortunately, we have this stupid virus, and I'm giving this lecture to an empty classroom, and I can't show it to you. So the best I can do is show you this video. So please enjoy this little clip. What? Okay, so when you drop the magnet through the copper pipe, it's almost like it's defying gravity. You guys need to figure out what's going on. Okay, that's going to be part of your assignment. All right, moving on in the chapter here. If you actually look at page, come on, there we go, page, what is it, 355. you could see these diagrams for electric circuits, okay? So I actually have a little circuit built up right here. And it's only going to light up the light bulb if it's a complete circuit, okay? So watch the little light bulb. There it goes. Can you see it lighting up? Okay. What I've done by unattaching this wire, by disconnecting it, is I've kind of produced my own little switch right here, okay? Once I attach it to everything else, I'm making a complete circuit, and the battery or the light bulb lights up, okay? So the light bulb for this is the resistor, and I'll define that for you on the next page. And the battery is given a symbol like this. So whenever you're looking at circuit diagrams, there's the same kind of symbols used. The lines are the wires. This open and closed door thing is the switch. If that was closed down like that, it would be a complete circuit already. This little zigzag line is like a light bulb or some other resistor. Again, I'll define that in a minute. And then those parallel lines right there is the battery or just another energy source, okay? Could be something plugged in. So I've got another light bulb. One wire is attached. I'm going to go ahead and attach the other wire to it, and you can see it light up nice and bright. It's brighter because this is actually plugged into an outlet, so there's more volts going through. You'll learn about volts a little bit later, okay? Again, an incomplete circuit, complete circuit, okay? All right, some additional vocab. If you guys need to, let me go ahead and get all of these on. If you guys want to pause the video to get this down into your notes, that's just fine. So a circuit is that complete pathway, okay? Again, it has to be everything touching, okay? The switch is open right now, the switch is closed, okay? So a complete circuit is the only thing that allows that current to flow through everything, okay? Resistance is an opposition to that flow. Something is causing the flow of current to be restricted. For our circuit right here, that's the light bulb, okay? So a resistor is an object that resists the electricity. So what I've got right here is this old school light bulb, okay? The part that glows is actually a special kind of wire. Thomas Edison spent years trying to figure out what material he could put in there. So you see these other wires that aren't glowing, okay? The light bulb would be plugged into something. There'd be electricity flowing into this, okay? It's going to go through this wire here. And then this filament is a resistor. It's almost, you can think of it as like friction, okay? So as the current is going through, it's slowing it down, and it's actually producing quite a bit of heat. So that filament starts to glow. It heats up and it glows, okay? The little filament inside of these light bulbs is doing the same thing. If you could see this close enough, you'd see that there's a little filament, and it's just resisting that electricity, and it heats up to the point of glowing, okay? Well, once it gets through that little swirly thing, it's going to travel back down this wire and then back out that way to the rest of the circuit. There'd be some energy source right there, okay? And that would be our complete circuit, okay? I think that's it for this section. Hope you guys are doing well. I miss you. See you soon.